Hi, good day. Today we would like to talk about the chapter 1, basic concepts and law for the FEP 101, basic electrical technology. Uh, so what to learn in this chapter is we'll talk about the system of a unit, charge and current, voltage, power and energy, circuit elements, Ohm's law, nodes, branches and loops, Kirchhoff laws, series resistors and the voltage division, parallel resistor and the current division. So introduction, what is an electric circuit? Electric circuit actually is the interconnection between the components of electrical devices for communicating and transferring energy from one point to another one. And then the components of electric circuit are always referred to as a circuit element. All the components we call it as a circuit element. So, and then the first part is a SI unit. SI unit we call as an international system of unit. It's used by all the major engineering societies and most engineers throughout the world. So it was adopted by the Institute of Electrical and Electronic Engineers (IEEE) in 1965 and by the United States of America Standard Institute (USAC) in 1967 as a standard for all scientific and engineering literature. So SI units can be classified into base units, derived units, and prefixes. So I will show you what the examples are. So the base unit actually we come across last time from time to time. We have a length, the base unit is a meter, symbol is M, mass, kilometer, kg, time, we use second, S, electric current, ampere, A, temperature, Kelvin, K, amount of substance, mole or MOE, luminance intensity, we use a candela or CD. And then if the derived unit is something like we can combine all together and derive to become like this. So for example, frequency. The name is of the unit is hertz. Symbol is Hz. So we can derive become S minus 1, which is equivalent to 1 over S. So the basic is second, but 1 over S become hertz. So that's why we call as derived unit. It is derived from the base unit. Base unit cannot be derived, okay? Force, the name is a Newton, and another equivalent SI unit is a meter. Dot is times, meter times kilogram times second to the power minus 2, which is divided by S power 2. Pressure, we use Pascal, PA, or Newton per meter square. Energy, we use Joule, J, or we use Newton meter. So and so on. For example, power, we use watt. Electric charge, we use coulomb. Electric potential, we use volt. Electric resistance, we use ohm. Celsius temperature, we use degree Celsius. Degree Celsius, okay. So this is the symbol, and then this is the equivalent SI unit. So in the SI prefixes, another one is SI prefixes. For example, how big is the hard disk storage? Sometimes you say, oh, my one is a SSD 250 gigabyte or 500 gigabyte. This is called prefixes. So we have a tera, giga, mega, kilo, hecto, deca, deci, centi, milli, micro, nano, pico. This is all the prefixes we usually use. For example, tera is a 10 to the power minus 12. That means we have a 12, 0 here. Giga is a 10 to the power minus 10 to the power 9. This is 10 to the power 12. 10 to the power 9. We have a 9 0 here. 10 to the power 6 mega, 6 0 here. Kilo, 10 to the power 3. We have a 3 0 here. Hecto, 10 to the power 2 is a 2 0 here. 10 to the power deca, 10 to the power 1, 10. Deci, centi is a 10 to the power minus 2, which is a 1, 2. Milli, 10 to the minus 3, 1, 2, 3. Okay? Micro is another 3, 0 here. Nano, 10 to the power minus 9. Pico, 10 to the power minus 2, minus 12. So we have a tera, giga, mega, K is kilo, and so on, yeah? Next, we will talk about the charge, current, voltage, power, and energy. So charge, this is the variables. Variables means something like we define in words, but the number will be keep the value of the value for that every variable is changing depending on the calculation. So charge we use Q usually, and then the unit is a coulomb. Current in ampere, voltage in volt, resistance in ohm, power in watt. So electrical charge is a property possessed by both electrons, which is a negative charge, and the protons, positive charge. So quantity is we call it as a charge or Q. Base unit is a coulomb, C. For example, charge is equal to 15 coulombs. We can rewrite as a Q equals to 15 C. Please bear in mind we can see that Q is actually italic. Italic means it is a variable. Variable means the value can be changed in any condition. For example, now I don't want to use 15 coulomb. I want to use 10 coulomb. Then the charge for the instance will be 10. But the symbol for the SI unit will not italic. Will not italic. The current is okay. Current is a movement of charge in a specific direction. So, for example, the electron negative move from a negative to positive area, positive terminal. So the movement of the charge electron. So electric current terminology, we use a current I, italic. Base unit is ampere, A. An ampere equals to a coulomb per second. So 1 C divided by S. Correct usage is current equals to 12 amperes. I equals to 12 N. So as we can see that I is actually the variables. A is not. A is a symbol or unit. So electrical current relationship. Previously, what we learned from maybe secondary high school. Current is actually charge divided by T, time. Or we can write in a symbolic way. I equals to Q divided by T, where I is a current in ampere, Q is a charge in coulomb, T is time in S. So IQT is italic, ACS are non-italic. Example, the charge flowing through the imaginary surface is 0.16 C coulomb every 64 milliseconds. So milli is prefix. Milli means negative minus 3. Determine the currents in amperes. Solution, we apply this formula. I equals to Q divided by T, where 0.16 coulomb, 0.16 coulomb, divided by 64 times 10 to the power minus 3, because this is milli, equals to, so 160 times 10 to the power minus 3, become 2.5 ampere. Types of currents. We have two types. One is a DC current, one is a AC current. DC current is a current that remains constant with the time, so it is constant. AC current is the current that varies sinusoidally with the time. One it will go to positive plane, one it will go to negative plane. Current source. What is current source? Current source is the device that can generate a prescribed current. Prescribed current means the current that we want. For example, now I connect my current source in a circuit. I assume that I want to maintain this circuit in 10 ampere, so I set 10 ampere. No matter how the load change, it will still 10 ampere. So device. What is device? Device is something like our handphone, our computer, electronic devices, instruments, all are called device. So it is an instrument device that can generate a prescribed current, the fixed current, independently of the circuit which is connected. Independently of the circuit means no matter how I change the circuit. Let's say I set 10 ampere, it will always 10 ampere. Voltage. Voltage is actually the electrical pressure or force that causes a current. We can say as a potential energy difference between 2 points, or an electromotive force, EMF. Or in a simpler way, for example, waterfall. Waterfall is a falling from the high altitude to low latitude. So, do you see before the waterfall is flowing from low to high? No, actually no. Voltage also the same. If there's a waterfall, there will be a voltage. If there's no difference, that means the voltage will be 0. If there are voltage, that means there's something voltage. For example, this is plus minus 10 volt. So it becomes plus minus 10 volt. Huh? That's why we call a potential energy difference. It is a potential energy difference. And then the voltage terminology will be voltage. We can use E, we can use V, base unit volt. A volt equals a joule per coulomb. 1J divided by C. So example of a correct usage, if let's say my voltage is equal to 32 volts, I can write as a V equals to 32 volts. So we can have a look. This V actually is italic. Means it is a variable. It is not a volt. But this is not italic. This is a unit we call as a volt. So voltage relationship related to the energy and charge, which is voltage equals to energy divided by charge, or V equals to W divided by Q, where I forgot the italic. VWQ, V equals to voltage in volt, W equals to energy in joule, Q is charge in coulomb. So for example, find the voltage between 2 points if a 60 joule of energy are required to move a charge of 20 coulomb between 2 points. Always the voltage will be between 2 points. Either this point and this point. Then when it is the same level, there's no voltage difference, will become 0. So V equals to W divided by Q. My W is 60 joule. My Q is 20 coulomb. So I have a 3 volt. So what is the symbol of the voltage is like this. The long one will be positive, short one will be negative. And then it will cause a current flow. The current always flow from the positive, go outside to the circuit and back to the negative. That's why we call as a device that can generate a prescribed voltage, no matter how the terminal or how the circuit change. So direction of the current is flow out of a positive terminal. So voltage source, if it is constant, means if let's say I set 20 volt, no matter how big the resistance I give it in a circuit, the voltage will remain 20 volt. So resistance. So resistance is the opposition a material offers to current, which means if let's say I want the current to flow, but the resistance, the device, it will stop the current to flow through. That one we call, the material will call resistance. Resistance is determined by type of material, resistivity. Either we use a wire, we use a wood, plastic. This is called material. Temperature of the material. Is it hot, cold? Cross-sectional area. How big is it? Length of the material. Resistance terminology, we call resistance as R. Italic as well. It is variables. Base unit is in ohm. An ohm equal a volt per ampere. So correct usage will be resistance equals to 47 ohm, or I can rewrite as R equals to 47 ohm. Resistance relationship, it can be resistivity times length divided by the area, or R equals to KL divided by A. So for example, what is the resistance of a 20,000 centimeter length of a copper wire with resistivity of 1.4 times 10 to the power minus 6 ohm dot centimeter at area of 0.28 centimeter square? So I use this equation, R equals to KR divided by A. So what is the value of my K? K is my resistivity. So it's 1.4 times 10 to the power minus 6. Remember, this unit is under centimeter. So I need to have times length in centimeter as well. My length is in centimeter, but I put it in scientific way. It becomes 2 times 10 to the power minus 4. 10 to the power minus 4 means I have a 40. 1, 2, 3, 4. Then divide by 0.28 centimeter square. So I have a 0.1 ohm. Conductance. Conductance is a measure of ability of an element to conduct electric current. Just now is a resistivity. So I reciprocate it, means I divide it, it becomes conductance. We call as an inverse of a resistance. The unit will be in a Siemens. Siemens, I forgot to italic it. G equals to 1 over R, or inverse of resistance, or I divided by V. We call it as a conductance. So for example, determine the conductance of a 50 kilo ohm resistor. Solution is G equals to 1 over R, whereby is 1 over 50K becomes 0.02 millisecond. Millisiemens. And energy, okay, energy we have a few selection. One is a work. It consists of a force moving through a distance, energy, which is the capacity to do the work, the joule, the base unit for both energy and work to be done. Interconnection, the amount of work done equal to the amount of energy used converted. So 50 joules of energy are required to do 50 joules of work. Actually, it's a equivalent. And then it is related to the power. Power is the rate of the using of energy or doing work. So what do we mean by the using energy? Using energy means the energy is being converted to a different form. Like kinetic energy, we convert into static energy. Something like this. Heat convert into anything can be converted. Kinetic energy like this. So the power terminology, P, quantity, base unit will be watt. A watt equals a joule per second. For example, the correct usage, 1 watt equals to 1 joule per second, or J divided by S. Sometimes we use 1 horsepower as well, equals to 746 watts. So the relationship is power equals to energy divided by time, where we use P equals to equals to W divided by T. Then the power delivered to or absorbed by an electrical devices or system can be found in terms of the current and voltage. Just make it easy. Now I want to derive and relate it to the current and the voltage. So first I use P equals to W divided by T. Okay, then I know that from previously, from the slide above, that we have mentioned, V equals to W divided by Q, work divided by charge. So I substitute this one into W. I have V times Q divided by T. And then at the same time, I know that my current equals to charge divided by T. So my Q divided by T actually is my current. Conclusion, I want to get this one. My power equals to V times I. So by direct substitution of Ohm's law, what is Ohm's law? Ohm's law is V equals to IR. The equation power can be obtained by many forms actually. We can P equals to VI, then equals to V, I substitute I. So I change I equals to V over R, so I have a V square over R. If let's say I change V, what is V? V equals to IR. So IR is here, times I become I square R. Okay? Next, we'll talk about the circuit elements. A circuit element, we have two types. One is an active element, one is a passive element. The problem was, what is active element? What is passive element? Active element is the elements that is capable of generating electricity. What is that? For example, voltage, current sources, all are capable of delivering energy or give energy, like power supply, generators, battery. Passive element is incapable of generating electric energy. For example, it consumes it, or resistor, inductor, capacitor, diode, and so on. Passive element. Okay, and then source. Okay, source we have two types. Just now we talked about source, right? It's subdivided into two types. One is independent source, one is a dependent source. Both of them also have two types. One is a voltage, one is a current. One is a voltage, one is a current. Do you still remember the previous slide that we mentioned? In the voltage source is something like when we apply 20 volt, no matter how the component change, it still maintain 20 volt. Okay, okay, then we have voltage, we have current, we have voltage and a current, and the symbols are different. What is independent source? It is an active element generating electricity, right? And then it provides specific specific voltage or current that is completely independent of other circuit elementaries. Yeah, so we have an independent. We talk about ideal independent voltage source, or ideal independent current source. If ideal independent voltage source, the terminal voltage across the source fixed. The voltage is fixed, but current in the circuit will change. If the current source is independent, means the current in the circuit will be fixed, but the voltage across the source will be changed. This is the relationship. Dependent source, it is active element as well, but from the words we know that it is depend, which means we need to trigger it so that the value will change according to what we have triggered. So the source quantity is controlled by another voltage or current. We have four possible types, like voltage control voltage source, current control voltage source, voltage control current source, current control current source. This is the ideal voltage source connected in series. V1, V2, I connect plus, minus, minus, connect to the plus, then minus. It become like this one. Ideal current source, I1 plus I2 become this one. Circuit elementaries for the resistor. Resistor is component used in circuit to control the current. Units are ohm. Type of resistor, we have a fixed resistor. We have a variable resistor. Fixed resistors are made of the metal film, high resistance wire, or carbon composite, and the symbol are this. Variable resistor has a terminal resistance. This is terminal resistance. We can vary it by tuning a dial, knob, a screw. This is variable resistor. Then we can control it. This is a fixed resistor. Okay, fixed resistor. Different wattage. This is 12 watt, 30 watt. This is half watt, quarter watt, 1/8 watt. Ohms are also different. So we have a different values band as well. This is the resistor color code, and every color code are representing a different values. For example, black will be 0, brown will be 1, and so on. And there's an acronym. There's an acronym to remember this code. For example, black, or better be ready, or your great big venture goes west. Better be ready, or your great big venture goes west. This is how we memorize all the color code. Then how to read it? For example, now the first one I have a yellow, violet, red, and also silver. First yellow. Yellow is the first digit, which is first stripe. Yellow represents 4, so I have 4. Violet. Violet represents 7. 7. Multiplier. It is red. So multiplier red, it is times 10 to the 100. So times 100. So what is the tolerance? This is silver. So silver give me a tolerance of plus minus 10%. So so R will be 47 times 10 to 100 plus minus 10%. Become 4700 plus minus 10%. Next, we have a circuit elements of a capacitor. We construct simply of a two parallel conducting plates separated by insulating material. For example, air. For example, inside this air, it becomes a capacitor. So these are the example of this capacitor. And the unit, we use a farad. Okay? A capacitor has capacitance of 1 farad if 1 coulomb of charge is deposited or stored on the plate by a potential difference of 1 volt across the plate. So if the charge stored it on the plate, we can generate 1 volt across the plate with a 1 coulomb of the charges here. Then we have 1 farad. Then electric component. Circuit elements of an inductor L. We use L. It is an electrical component that opposes any change in electric current. Resistance is opposed to current. When the current comes, we stop it. But inductor is different. Inductor is when it want to come, which means at first the current inside the inductor may be 0. But when it comes into the inductor, it say, hello, I want to increase your current. So the inductor will say, no, 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 I will try to reduce your current. That's why we call the electrical component that opposes, or you don't want to let it go through, but in fact it will go through. Any changes in electrical current. So it's composed of a coil or wire wound around a non-magnetic core or magnetic core. This one, we wound it. And the unit is Henry. Its behavior based on phenomenon associated with the magnetic field, which the source is current.